Hello, everyone. So first of all, today we'll go through some discussion points. I'm going to point out here GDPR and the complexity of the environment. I will also go through some stats around Thales data threat reports. Not all the stats; it's a huge report, but we'll just point out some, short, important points relevant to this discussion. If anyone needs the largest report, we can perhaps share it later. Then I'll discuss the data security in multi-cloud, which is becoming a relevant and important subject these days. So digital transformation is obviously a big deal. Every aspect of our lives has been digitalized these days. Every picture, every journey we take, every payment or purchase we make, our health records and our hobbies, all our information is collected by organizations, stored and traded by organizations and governments. So there is no limit to what organizations and people can do with this data. Obviously, GDPR actually came to save, to help us or to help European residents to be protected and data be protected worldwide. Worldwide because it applies to all organizations wherever they are, as long as they store European data, European regions data. It tightens really the laws so organizations can be limited to what they can do, and it went to effect in May 25th, 2018. That's exactly a year ago, and it has a huge effect on businesses. We don't have a complete stats of what's happening out there, but GDPR is on and kicking. So just to remind you of some of the importance of security within GDPR and data security. A couple of articles here, Article 32, which actually focuses on security, which clearly ensures that processors implement appropriate measures to get the right level of security, and it always goes back to pseudonymization and encryption of personal data as an important technique of protecting data. So Article 33 actually mandates that organizations must notify authorities within 3 days of the discovering the breach, because it might be breached for a long time, but you will only discover it at some point. So 3 days after discovering the breach. So not only notification of the organizations, but also Article 34 specifies that data subjects must also be notified. However, Article 34 states that the organizations are exempt if they implement appropriate measures, mainly if they render the personal data useless to whoever accessed it, an authorization, or does not have authorization to access it, yet had access to that data. And once again, to render it useless, encryption was suggested as a good technique to do that. So typically, pseudonymization and encryption have been repeatedly called out in GDPR as great techniques to protect the data. So, however, the complexity these days of the environment became a barrier, especially given multi-cloud data centers, multi-kind of databases, and all these mixed environments. So it's becoming a barrier for people to reach the level of security they'd like to. And we have compiled a report. This is where the data threat report come into play. This shows the respondent demographics. We ran, basically we interview a lot of senior IT security executives, over 1,200 from Americas to EMEA to APAC. And this slide shows the level or the size of organizations in terms of revenue that we have interviewed. So the questions we ask are far beyond just the environment. They are related to security, etc. So here we show that 44% of respondents rated complexity as perceived barrier to implementing data security. Far actually more than the resources or staff or budget or even executive buy-in into, we need to protect data, we need to reach this level of security. So the complexity became an important factor or an important and a huge blocker of achieving the security people or customers or organizations needed to. So each environment and often each implementation within the environment requires a kind of unique security approach, pretty much because the applications are different and different clouds provide different tools, etc. Now, what we have also found is the sensitive data is widespread in digital transformation environments. So 97% of respondents use sensitive data within digital transformative technologies like big data. They rush into analytics, into containers, into clouds without protecting that sensitive data. Only 30% of these respondents are using encryption within these environments. So the 30% does not mean only 30% of the people are actually using encryption and data protection. The 30% is just within these new technologies specifically. So, and obviously, because of a low security, data breaches are becoming higher and higher. So this is very informative as well here. 60% of the organizations have been breached ever in the past. This number may be even higher because we know that a lot of organizations don't want to talk about how often or about their breaches. So only in countries or areas like, for example, in California, organizations have been pressured to notify for years now, so we always know when someone gets breached. And these same laws or rules have been adopted by other regions as well, but not everywhere yet. So 60% is still pretty high. Breached just last year is 30%, and breached multiple times is 14%. So the point we always make is no one is immune, and that's also been a big message from the data threat report. So no one is actually safe. Everyone will be breached, and that is the reason GDPR insists of just render the data useless, at least encrypted or tokenize it to achieve pseudonymization. So because it will be accessed by people or hackers that are not supposed to access it anyway. So make sure they don't use it when they access it. So obviously data privacy is what helps to eliminate some of those breaches and those challenges. And it is becoming the leading driver in adopting this encryption and security. So we have heard like 89% of respondents say that their organizations are affected actually by data privacy regulations these days. So, and how will they meet? How will they meet these regulations? How will they achieve it? I mean, most of them again answered that encryption, tokenization, and this is not just the answer of the organization. This is also what we see the regulations insist on: encryption, tokenization, moving to compliant locations and cloud providers that obviously provide good security as well. So let's now talk about some security and align it to how to approach it and what's happening out there and what kind of mechanisms can be used, etc. So first of all, data security and who's responsible for it. So to answer the question obviously the answer is it's shared amongst the providers and the owners or the customers, the data owners. So if we look at the typical environment these days, either you deploy on-premise, where customers have a control over applications and operating systems and file systems, databases, storage. In that case, customers or organizations have a lot of power to implement security in any way they like, or obviously on the cloud or hosted services. As we go the right side on this, to the right side on this slide, it can be infrastructure as a service, where the lower portion, like storage and the network, is taken care by the provider, or platform as a service, where actually you only have access maybe to the application. You might write the code, but you may provision a database and you don't know where that database is. So it's pretty much, which means that limits you what you can do to that database. You may integrate your security just at the application layer, for example. And then the SaaS, which is software as a service, where you have actually less power. Everything, the encryption and data protection may be provided by the provider himself. So as we move from left to right, you have less power on what you can do, which means you can settle for what the provider is providing you in terms of security. But on the left side, on the other hand, you can implement any level of security. However, the customer still owns the data, which means we are still responsible for most of data security. It's not like we're shifting our data or our environment to third party and we're all fine. We still have to actually be responsible. So what do we do? Encryption, obviously, is what I'm going to talk about, some high level of encryption and key management. So the typical environment is when let's assume the case when we host our environment, or we use SaaS or platform as a service, and the provider actually provides encryption for us. In this case, the encryption style and type and level of encryption is also dictated on us. Well, at least we need to bring your own key in this case. We need to at least manage our keys and make sure where they are used and what services, and provide them, push them to the cloud provider. But again, we need to make good decisions on what data, how sensitive that data that will be hosted and encrypted by third party. So that really depends from organization to organization. And the other mean of encryption is perhaps it's an extremely sensitive data that I'm not even going to allow third party to encrypt it for me, whether in the cloud or on premise. I can bring my own encryption. Bringing my own encryption means I will really apply the level of encryption I want, perhaps with access control, perhaps at the database layer, etc., because different layers obviously provide different level of encryption. And let's talk about that a little bit here. So the most important questions to always answer when talking about encryption is, who am I protecting against? And once that question gets answered, we can decide what level of encryption or what level of data security we can apply. So if you look, so one of the reasons we're insisting on encryption is because, again, in GDPR and the regulations and compliance are insisting on it, is it's the only technique that remains with data, first of all. The only technique. The assumption is we're going to be hacked anyway. But then, again, like GDPR says, at least render the data useless when it's hacked, and encryption and pseudonymization are the only techniques that can move with that data and to make it, to render it useless. So that's why the question of who are we protecting against is important. So as the data gets generated somewhere and flows through applications where it gets processed, to the databases where it may be stored, and database is stored in the file system, and there's always a storage underneath. The encryption or the data protection can happen actually at any layer. And the data, it's the same data that flows, but it can be captured at the application layer or database or file system or storage layer and be encrypted. So every layer provides different level of security. The earlier you capture the data and protect it, let's say we integrated the application layer when possible and tokenized fields, that means we are in a better, that means we're providing a stronger security. That means we can even store data within database, and even the database administrator will not be able to read it in that case. But what about perhaps we will just capture it at file level? Let's say they're just files. We can capture files and encrypt them and apply access control and make sure that decryption can only happen by those who those who suppose to actually read those files. They can be applications or business units, etc. Now, for example, when you are doing platform as a service, you are abstracted from these low levels. So you don't have a power to apply any strings. You have to settle for what the provider is providing. So again, all these levels, obviously, they will have to point to an external key management, and the external key manager decouples the keys from data. These are best practices. But again, just saying encryption as a checkbox is not enough. Different level of encryptions at different layers provide different level of security. The earlier we capture data, the better, and the encryption and the keys have to be decoupled from the data. Okay, so that's on bringing your own encryption gives you a lot of power. But what happens in GDPR with GDPR and the identification use cases? Meaning, you have a lot of data. Customers have a lot of data that they will eventually release. Well, first of all, databases. Let's just pick a database. You have a database. Sometimes you want to provide it to a QA or to a third party for testing. How do you protect that database, right? Or you, for example, let's point out these examples here, healthcare. Pulling data of the last 100 years for some sort of research. Here as an example, looking for subset of patients with specific conditions or treatments. We'll have to expose that data. Or financial services looking for people with some level of wealth or financial behavior. Or insurance, for example, looking for what corners of the city are dangerous, or who are the individuals that are risky for the insurance. Or retailers want to know more about the products, what's sold, what's not, what prices make sense, etc. So to do all these, or in history, to do all these, this data has to be exposed. And we have seen a lot of organizations do this. However, before it gets exposed, it has to be de-identified. Otherwise, people will make sense. Will look at the subject data, will expose users, and that's what GDPR is against. That's what it's all about. As another example, there's in U.S. HIPAA Safe Harbor, which is you must anonymize at least 18 records from name to first name, last name, etc. So this identification is extremely important. Now, what we have seen in the field is some people have not done it right. They rushed to provide this data. They hashed some fields with standard basic hash functions, and they exposed it to third party. And we have seen hackers and researchers cross-referencing that data with the public data and figuring out who's who. So this has to be done right if we ever expose information for any purpose. Notorious samples for these hacks are the governor of Massachusetts. The medical records were exposed for research, but with some basic security, and people were able to cross-reference it with photo list. They figured out the governor's medical records. Netflix, same thing, a similar use case. You can Google it. New York New York City taxi drivers. The data is exposed as well, or actually provided. The data is provided with some basic hashing and security. No key management, no good techniques. So researchers were able to cross-reference it with public data. They were able to find out celebrities and what trips they took and what tips they gave, and they found who's the driver and where they live and all that. So again, this is where we propose some good techniques. I'm showing here as, for example, pseudo security being an input. So first of all, an external key manager should exist, and then we have to apply strong techniques, encryption, HMAC, format preserving encryption, tokenization, etc. Not just a basic hash. These techniques with the key management cannot be reversed. They're strong for anonymization and can help in all these techniques, all these use cases. So as we move forward, as I talked about the past couple of slides, I talked about bringing your encryption where you have more power to apply the strengths you like. But now here, what I'm showing is bring your own key for multi-cloud. If you're using platform as service like Office 365, or using Azure database or RDS in Amazon, in this case, in some cases like Office 365, encryption is dictated on you because it's applied. I think it's just full disk encryption and it's applied by Microsoft. Now, they provide encryption, they provide key management. You'll have to bring your keys. And to bring your keys, you pretty much have to generate them somewhere else. You can settle, if you want, for the key being generated by the provider as well. But now you're providing all the power to the provider. Now, you'd rather have at least you bring your own key, the minimum you can do. But then if you do it, you also want to do it in a way that actually centralizes bring your own key for all the services you use. And then for the multi-cloud, to simplify the story of multi-cloud complexity that we started with. So gives you visibility to all the keys that are used for all the services. You'll be able to rotate them as you like, to audit them, etc. One single pane of glass, basically, for all the platforms. Otherwise, you'll have to bring your own keys for different clouds, with different interfaces, a lot of learning, and it's hard to maintain what services using what keys. So that's the other aspect. But again, plan for multi-cloud. Data is dynamic. You want to move from cloud to a cloud. You want to use different services. Sometimes you're happy with SaaS. Sometimes infrastructure as a service, and obviously sometimes also on-premise. So as you're looking for these tools, look for something that's centralized, multi-cloud, centralized, minimize the silos, look for a platform. So basically, think multi-cloud, think platform. Platform, what I mean with platform is a key manager, for example, that provides a lot of a huge ecosystem. May even have an HSM as a part of it that provides all the PKI, all the signing, the code signing and document signing, key management that's integrated with storage, that applies bring your own key, etc., that provides you dispatches keys to encryption, tokenization, etc. And again, an ecosystem and partnership so that you can actually find, you can cover multiple use cases with a smaller amount of platform. To conclude with this slide is really, again, the point is the complexity is there. The data protection is a long-term game. Think about strategy, about long-term, about platform, about multi-cloud, and the data security is an ongoing game. It's not start small and move on to cover all your use cases. It never stops. But again, if you have a strategy and you have a comprehensive solution or a platform that provides comprehensive solution, it simplifies your story. And that's all I have today. This is just a slide. We'll share the slide and it points you to some additional resources.